All right, so let's solve this problem. Okay, and before we get started, I just want you to think the idea of this process, the purpose of this process is to basically predict the outcomes of traits that a child will express. Okay, so basically this is like the prehistoric way of determining what traits your baby is going to have, right? Like it's an old school way of predicting it. So that's what Punnett Squares really are. All right. So first things you always want to do is identify the information you know. It sounds very familiar. Kind of sounds like a math problem, right? Cool. So we know that the dominant allele for whiskers is long whiskers, and it's coded by a capital W. The recessive allele for whiskers are short whiskers, and it's coded by a lowercase w. Now, what they mean by dominant and recessive, right? Basically, dominant is that trait that majority of the offspring usually produce. So whenever you see a seal in the zoo, most times they usually have long whiskers. So that's why it's considered a dominant allele. Okay. You don't often see seals with short whiskers, so that's why it's considered a recessive allele. So when something is dominant, chances are majority of the offspring of that species or population, whatever you want to call it, they express this trait more often than they express this one. That's all. All right? So we know capital W, lowercase w. We also know that parent one, let's say it's mom, is homozygous dominant. What that means, mom got two alleles from her parent, one from her dad, one from her mom, and they were both dominant alleles. So guess what? This mom has long whiskers because she inherited those traits or those alleles from her parents. All right? And then dad, he's heterozygous, meaning he inherited a dominant allele from his mom and a recessive allele from his dad. Okay, so he has the ability to express both traits, but because he has a dominant allele, he'll never express the short whiskers. However, he's going to pass on this allele to his offspring. All right, and so that his offspring will have the potential to have short whiskers, but it will never express it because he's also sharing a dominant allele with them as well. All right, so that's what you need to think, how you think of these things. It's not about like the literal things here. It's also about thinking like realistically. Basically, we're predicting what will the offspring have, what traits will these offspring display. All right, so now we're ready to do our actual cross. So again, we're doing a cross. Think of it as cross multiplying. Whatever you do here, you're going to multiply this value by that, this value by that. You multiply every row by every column. All right, so before you start multiplying or crossing, you write the genotypes of each parent across the top and across the side. So I'm going to do that here. I'm going to write mom across the top, and I'm going to write dad down the side. Okay. Voila. So now we have that. Now we start doing the crossing. So this is how we cross. Capital W times a capital W will give you two capital W's. Remember, every row times every column. So we did row 1 times column 1. Now we're going to do row 1 again times column 2. Okay? Capital W times a capital W will give you two capital W's. All right. Now we're going down to row 2 because we have no more columns to cross multiply. So here we go. Row 2. Lowercase w times a capital W. What will that give you? Fill in the boxes. Okay. I'm going to do it again. Row 2 times column 2. Lowercase w times a capital W. Voila, you've completed the cross. Now, before you start doing the probability of for the problem, you need to identify what this means. Okay, so mom and dad decide to have a child or a baby seal, and they, let's be real ridiculous, but thinking about it, they decide to go to the seal doctor, and the seal doctor's like, well, here are the outcomes. Here's the possible outcomes of what your child is going to express. So the seal doctor is going to basically explain to them, all right, we took your pairs of alleles for whiskers and dad's pairs of alleles for whiskers and crossed them to see what possible phenotypes or traits or whiskers your baby seal is going to have. And so we need to identify what this means. So look at the first result. 2 capital W's, this baby is going to have could potentially have long whiskers. Look at the second box. 2 capital W's, baby's going to have long whiskers. Now, this is where everybody gets tripped up. Down here, you have a lowercase w and an uppercase W. Now, remember what I told you earlier. If you see that dominant allele code, you are automatically going to have that dominant trait. So let's look here. This baby has the potential to have short whiskers, but because this cross came with a dominant allele, it's going to show long whiskers. Dominant always knocks out recessive. And the same here. Because there's a capital W in that box, this baby is not going to express the alleles for short whiskers that it does have, okay? So again, to summarize, when completing Punnett squares, think of it as the old school way of predicting what traits your babies are going to have, all right? And so mom and dad are basically giving their traits that they inherited from their mom and dad, their parents, and crossing them to see what the possible outcomes are. That is all we are doing. Now, the question now, going back to this problem, it asks, what's the probability of this baby showing or displaying short whiskers? Hello, we just came up with the answer. Long, 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 long. The probability, boys and girls, is 0%. This baby's not going to show anybody short whiskers because it doesn't have that as a possible outcome. The only way it would have had it as a possible outcome is if we saw 2 lowercase w's in any of our boxes, but we don't. So therefore, the probability of this child having short whiskers is 0%. All right, back to the video.